So if you have any questions about your course schedule or anything in general, they are available for you. Okay. I am still admitting people, so give me a second. Okay. So I'm putting the sign in the chat. And I would like to remind everybody that we actually have a fun game night coming up on Thursday. And there will be prizes for our incoming transfer students. And so if you are interested in having some fun with our learning assistants and playing some game night trivia, please join us. Our basic training and hack mentors are also welcome, and you guys are also eligible for winning the prizes. Okay, people are still arriving, Austin, so let's give everyone a minute. Okay, for those of you who just joined us, please go ahead and sign in with the link in the chat. I was just querying everybody to see who has yet attended their new student orientation. I know that there was one last week. So hopefully you guys who did attend got some really great information. And for those of you who haven't yet, that you're looking forward to that and or have scheduled your message center advising with your counselor if you can't come to orientation. And just a friendly reminder that Thursday, our learning assistant mentors are planning a game night with some trivia and some drawing and some Cards Against Humanities. And there will be prizes. And so we do encourage you all to join us if you are free. These are for our incoming transfer students. So I do apologize to our El Camino students that this program won't be for you. Okay, I think everyone has arrived. So Austin, do you want to start our work session tonight?
Yeah, so now that everyone's here, I'll send the link to the slides. And can someone let me know if that works, please, in the chat? Okay. Thank you, thank you. I'm gonna share my screen really quick. Yeah. Okay. So welcome everyone to the Intro to Arduino lesson today. Last time at the end, if you remember, Jessica went over uploading a basic example sketch to your Arduino. So I expect that everyone is able to upload programs to their Arduino so we could focus on actually doing the programming and not debugging, getting it to work. So first, let's go over some preliminaries. So first of all, what is an Arduino? An Arduino is basically a circuit board around a microcontroller that adds a simple user interface. So the Arduino itself isn't just a microcontroller. I know you'll hear that, but it's actually this tiny chip here. That's the microcontroller. And that what a microcontroller is it's basically like a primitive computer that could do like simple operations and memory management. And so in the past, with just a microcontroller, it's really a hassle to use it because you had to code in like binary, essentially, remember a bunch of registers, and you needed some proprietary cables to like upload your code to it. But what Arduino did was they made a sort of ecosystem to allow you to upload programs using simple USBs and coding in a more human readable language. And the other preliminary we need to know is the difference between digital and analog signals. So the first thing I want to say is, if you guys have heard of like basic signals and stuff, or worked with electricity, don't confuse this with DC versus AC. That has more to do with just how signals vary. Analog and digital is more of a fundamental difference. So an analog signal is just a continuous signal with infinite resolution. So there's infinitely many values it could take on. And a digital signal is it's a discrete signal, which means it has a finite number of values it could take on. And that's kind of shown here in this drawing. But to get a better intuition of the difference between digital and analog, you are probably all aware of like a clock like this, whose second hand rotates smoothly. And so at any given position of the second hand, can you actually be sure like what time it is? For instance, I guess like in this image, it's around like 10, 15, and like 41 seconds. But since it moves slowly, it's like analog. It could be like 41.99998 seconds. So it has infinitely many values. But in a digital clock, for instance, it moves in discrete values, right? So you know the exact time like that the clock thinks it is, because it only moves in discrete steps. So I hope you guys have an intuition for the difference between digital and analog signals, because that's going to come up later when we program the Arduinos. So let me see if there's any questions in the chat. Okay. So let's actually get into programming the Arduino. So first of all, what language do we use? Arduino is programmed using essentially C++. It has its own like library methods and functions that it comes with implicitly, and we'll talk about those soon. But the fact that it uses C++ is a pretty good thing, because we already had a lesson on it, so we all know C++. But that's also kind of unfortunate, because we all know how suckish C++ syntax is. Yeah, so the basic structure of an Arduino program. So every sketch has these two functions, and what these two functions are is the following. So the setup function, the Arduino recognizes to call that function once every time it starts up. So what I mean by starts up is either right after you upload the code, right after you plug in the power source and the code's already uploaded to it, or after you press the reset button on the Arduino, which is this guy right here. So if you press this, then basically the memory is cleared in the Arduino, and then it runs setup again. And then the other special function of an Arduino program is called loop. And that basically is an infinite loop that runs continuously as long as the Arduino has power. So if you guys are familiar with like, I guess how video games work, it's similar to that, where loop would be the main game loop. It runs forever and always. Now let's talk about some useful built-in functions. So these are three of the functions that you're probably going to use in like most of your sketches or most of your programs. And the first is pin mode. So all pin mode is it takes in an integer that specifies what pin you want to set the mode of, and then the mode. And the mode is basically an enum, which has three possible values: input, output, and input pull-up. So, by the way, I guess this notation that I'm using, this is obviously the function name. And then these are going to be like arguments. And this is the type of the argument. And if a function returns a value, I'll write it like with an arrow syntax. So this is a return value. And another thing I want to note is these, remember how I said Arduino kind of like has its own built-in methods and variables? Well, like these are examples of that. Input, output, and input pull-up just are macros to like a certain number, which the pin mode function understands. Yeah, so it's pretty self-explanatory. If you want a pin to act as an input, in other words, you read from that pin, then you would set it as an input pin, and an output pin, you would write a voltage to, and we'll see that more in the future. And this last one, input pull-up, is a bit different. So I'll go a bit into this. Input pull-up essentially means if you have like a pin, say it's pin 18 on the Arduino. I won't draw the Arduino, but it'll essentially be like this. So say this is pin 18. And you want it to be an input pin, or in other words, you want to read what voltage is applied to that pin. And say it's connected to like a button or a switch, and then straight to ground. So if this switch is closed, right, then if you read from pin 18, it's going to say, okay, it's grounded, it's 0. But what about when the switch is open? What does it actually read? So basically, it's undefined behavior. This is what we call a floating pin, and it means it has like an undefined state. So what input pull-up means is if you have this sort of configuration where there's a switch and then it leaves your pin floating, then input pull-up essentially adds this. It adds a resistor to, I'll say, 5 volts. So what this does is when the switch is open, the state is no longer undefined. It's going to read 5 volts by default. Okay. And as you can see, like when the switch is closed, you're still going to read ground. Can everyone see that? There will be current flowing, but then the voltage at pin 18 will still be grounded. Okay, the next function is delay. And all delay does is it pauses the execution of a program for however many milliseconds you specify. Now, this is useful because sometimes you want this behavior, but in more complex programs, it turns out to be sort of a dangerous function because it will slow everything down. We call this sort of function blocking because as it's running, it doesn't allow other code to run. Now, that makes it hard to do multiple things. For instance, if you want to like turn on an LED and off an LED every 3 seconds, but you also at the same time want to read from a certain sensor, you're not going to get sensor readings during those 3 seconds if you're doing a delay for 3 seconds. So the fact that you're using delays to alter your LED timing is affecting the reading of the sensor. Now, in that case, we use millis. And what millis is it just returns the number of milliseconds that passed since startup. I guess if you've ever, okay, sorry, there's a question in the chat. Gabriel, what would slow everything down? I missed that part. The delay function would, because as long as it's as long as you call delay, it will stop program execution. That's just what it does. So for instance, in that LED and sensor example, you would ideally be constantly reading the sensor, whether you want to keep the LED state on or off. But then if you're using a delay after you switch LED states to keep the LED for 3 seconds at, say, on, then during those 3 seconds, you won't be able to read from the sensor because program execution is blocked. Is it possible to make the delay in async? No, unfortunately not. So this is like a big drawback of these like embedded devices. So Arduinos don't really have multi-threading capability. So you can't really run things in parallel. So you kind of have to work around it. Yeah. I'd say like that's probably the most difficult part of like programming Arduinos. So yeah, so millis, it just returns the number of milliseconds passed in startup. And this is useful because now this takes like an instantaneous amount of time to call, right? So back to our LED and servo example or sensor, instead of doing a delay for 3 seconds, we could just continuously each loop check, okay, how much time has passed, how much time has passed. And then as soon as like 3 seconds have passed since the LED has switched states, or like 3 seconds or 3,000 milliseconds, then we'll say like switch the state. But can you guys see that this isn't like blocking the sensor from reading data? Does this make sense to you guys? Okay, great. Okay, so those are the 3 built-in functions that I wanted to talk about for now. So now we could get into basic I/O, and this just means basic input output. So this has to deal with like reading voltages and writing voltages. So Sina has a question, is that like a pull-up resistor? The pin mode input pull-up? Yeah, that's exactly what it is. So like the true notation for this guy, we would call this an input or a pull-up resistor. Yeah. Okay. Good question. So basic I/O. So these are the 4 functions that deal with input output for an Arduino. And these are very important. So the first one is digital write. And all this does is it takes a pin number and a value, which is either high or low, and that writes that value to the specified pin. So as like high just means write. Sorry, I didn't mention on the Nano, it works with 5 volts. So when you say like output high, it means output 5 volts on that pin. And then outputting low would be just 0 volts. It would be ground. And this is all with respect to the ground on the Arduino. So actually, let me copy this image really quick. So the thing about these functions is some of them only work on specified pins. So for digital write, it will work on actually any GPIO pin, except the A0, A1. So by GPIO pin, I just mean anything that starts with D, essentially. So you can use this on all. Damn, I wish I didn't have that reset. Is that confusing? Should I? Yeah, you know what? I'm just gonna. My bad, my bad. Okay. So it works on all this, and then D13. Yep. Okay, so next is digital read. Is there a question? No. Digital read just takes one pin, it doesn't take a value, and then it returns either high or low. And so if you can, like, it's pretty intuitive, right? Like if 5 volts is being applied to the pin, then this will return high, otherwise it will return low. And there's some sort of threshold, like if there's, I think it's above like around 3.3, it'll read it as high, otherwise it'll read it as low. And this works on the same pins. But you would have to specify with pin mode that this is an input pin, right? Earlier. By the way, pin mode, sorry, I know I'm jumping around, but pin mode is called in the setup, like always. And delay in millis, you would usually be using it in the loop. Okay, yes. What is a pin? Sorry. So a pin is just, you know, on your Nano, it just has a bunch of like spiky things where like you could basically, are you guys able to see my camera? A pin is each one of these little circles essentially. And it's just like what you plug things into. I know that wasn't a great explanation, but did that clear it up a little bit? Like each one of these things is a pin. Okay. Does anyone else have questions? Okay. So yeah, digital write and digital read, they should be pretty easy. Does anyone have questions about them? And if you guys are a bit confused, don't worry, this will become more concrete as we get into like the examples. So let's go to analog read next. Analog read is basically like digital read, but it reads an analog value. So essentially, it no longer just outputs high or low. It outputs an integer, which represents how much voltage is being applied. Let me explain. So basically, under the hood, each analog pin, so this only works with pins that start with an A, which is going to be like these pins. So these are the ones you could use analog read on. And so remember how Arduino works with 5 volts? So basically the max value that it could return would correspond to 5 volts. Anything in between would correspond to like other voltages. So for our Nano, it uses an analog to digital, a 10-bit analog to digital converter, which just means the range of values that can be returned from analog read is from 0 to 1023. That's 2 to the 10 minus 1. So in our case, when we analog read something, if we get a value of 1023 back, that means it's reading, that means 5 volts is being applied to the pin. If we're getting a value of 0, it means 0 volts is being applied to the pin with respect to the Arduino's ground, of course. And then say something like 500 would correspond to roughly like 2.5 volts. Okay. Now lastly, we have analog write. And this allows you to, you can think of it as like outputting voltages that are in between 0 and 5. So in this case, analog write takes in an 8-bit integer. So it's values range from 0 to 225, where 225 corresponds to 5 volts, and then 0 corresponds to 0 volts. And then things in between correspond to like middle voltages, essentially. And this works with pins that have a squiggly. So it doesn't work with the A pins. The A just means like you could read analog values from it. It means like it has an analog to digital converter. And this is like a confusing point, so remember this. You can't write analog signals using the A pins. They have to be the ones with, usually they have squigglies when you look at a pinout sheet. So like the pinout sheet that I had over here, can you guys see that some of these guys have squiggly lines, like D11, D10, they have this little squiggle. So those are the ones you could use analog write on. Actually, on my thing, I don't know why it's just a dot, but oh. Right, so these are the ones you could use it on. Now, when you do analog write, it actually doesn't output voltages other than 0 or 5. Because basically when you output something on an Arduino, it only allows you to do like high or low, 0 volts or 5 volts. So they had to implement something a bit more clever, and that's what's called pulse width modulation. Now, this just means we could simulate with a binary signal. So binary meaning like it has 2 different values it could take on. The Arduino would be 0 and 5 volts. With that signal, we could simulate analog signals like in between those voltages using square waves of different pulse widths. And I'll draw this out for you. So the pulse width, the width of each pulse, let me just draw a square wave really quick. It would look something like this. Okay. And so it's on and off for a number of, or a certain amount of time for each period. And the percentage of time that it's on compared to like the time of the period is something we call the duty cycle. So in this case, let's say the period is like 1 second and it's on for like 3 seconds or 0.3 seconds. Then the duty cycle would be like 30%. Yeah, so basically, if you power an LED using analog write because you want to dim it or make it brighter, then this is what you're actually doing. You're not sending different voltages, you're sending a square wave pulse. It's just that your eye can't perceive the difference essentially. So let's just draw a couple square waves with different duty cycles just for reference. So a pulse or a duty cycle of 0 would obviously just be like a straight line at 0. And then one with 100% would be like up here. It would be constant at 5 volts. And then one with like 50%. You write these out. Does anyone have any questions? Okay, Mario had a question. Give me 1 second. Okay, let's draw one that's 50%. And Mario's question is, so we could technically observe this square wave by reading from an analog pin to a PWM pin, right? That's a great point. By reading from an analog pin to a PWM pin. Okay, yes. To a certain extent. So but depending on the Arduino, the frequency of this wave varies, but usually it's like really, really fast. And I don't know if your loop would run fast enough for you to actually see the behavior, like see the square wave itself. It depends on like when you're reading. Does that make sense? So you would need something like an oscilloscope. You would definitely be able to see it, because usually those can read up to like at least 10 megahertz. Yeah, thank you. Good question. Okay, and this would be 5 volts here. Any questions on PWM? Knowing this in practice, you probably like don't need it too much, but it's just good to know, because you'll see it a lot in documentation, especially. Okay. So now that we know like those fundamental built-in functions, we could look at a basic example and go through it together. So this is actually the Blink code that you uploaded at the end of last session. So now you should be able to understand it. So what this is doing initially when you upload the code, first, remember it calls setup once. And all that's in setup is pin mode. So it's setting this variable LED built-in to an output pin. And this just is an integer. I think it's a macro to the integer 13, because I think 13 is the built-in LED pin on the Nano. So it's saying that we could write voltages to this pin 13. Now, after setup is called, loop is called continuously. So the first thing in loop is we write a high signal to pin 13, and then wait for 1 second. And then we write a low signal to pin 13, so the LED wouldn't be on, and then wait for another second. And then we're calling this continuously looping, right? So we go back here, wait for a second. Yeah. Can everyone read this code? Do you guys think this is easy? Okay. Or let me ask, can anyone not read this code? Or like doesn't know everything in this example? In this case, we don't need digital read, and that's because all we want to do is control the brightness of the LED. So in this case, we do not need to digital read. Now, Adam has a question, can voltage only be written as high and low? In this case, since we're using digital write, yes. But remember, if we were doing analog write on a PWM pin, then we would be able to write PWM signals. Okay, Adam, is that clear?
Yeah, thank you.
Okay. Now, Gabriel has a question. What is the LED built in the pin mode for? So LED built in is like a built-in Arduino macro, or like you could think of it as like a variable. And actually in the slides, if you guys look at slide, I think it's the built-in one, sorry. Useful built-ins. This is actually a link to like a reference sheet that has all the built-in Arduino variables and functions. So LED built-in is just, it just corresponds to the integer 13. We could just replace it with 13, but the code is like this because it would work on multiple Arduinos with different LED built-in numbers. Jesse says, I think you can use 0 or 1, 2, and it has the same effect as high and low. I think you're right. Yeah, I think high just is a macro to 1 and low is a macro to 0. We could double check that by looking at the reference sheet I just talked about, but I'm not sure. Okay, Yeah, now it's already time for a break. And then we're gonna like take a 10-minute break. So we'll come back at like 6:47. And then we'll work on some examples and talk about interfacing with some sensors that you guys have in your kit. But before that, actually, Gabriel has a question. Can you go back to slide 13 where you drew out the diagram? Is it this one? I don't have the slide numbers. Oh, I do actually. This one.
Yeah, that one. Yeah.
Okay, yeah. Go ahead
We
and take
should
a
like
picture.
call the example. But yeah, thank you.
Yep. All right, I'll see you guys back at 6:47. I guess roughly 6:50. If you guys have any questions that you come up with, just send it in the chat and I'll either go over it instantly or when we come back from break.
Hi there. I think we're on a break, but maybe we can stop recording.
Following slides. Okay, the following slides should be on the drive now. Sorry, give me 1 second. Okay, while this is getting ready, any questions about the material we just went over? Okay. If not, that's good. Okay. Okay, so now we'll go over serial communication, or the very basics of it. And serial communication just allows the Arduino to talk to a separate computer or device. And serial in this sense does not mean the nutritious breakfast that we all know and love. It refers more to the serial that we use in like serial killer, where they murder like back-to-back individuals. So serial just means we communicate bytes in series, like back to back to back. And the serial, there's like a built-in serial object that we'll see the usage soon, but quickly the most important methods you're going to be using are going to be serial.available. That just, if a device has sent serial data to the Nano, then serial.available will return the number of bytes that is in the serial buffer. So when you send data to the Nano serially, then it gets stored in the Nano's serial buffer, which it could then read later on. Then serial.print is essentially the console.log. Oh, sorry. Yeah. Thank you, Wes. Serial.print is the console.log. It's, if you guys remember in JavaScript, we do console.log so that we could see messages that we want to print out in the console. And similarly, serial.print allows us to see messages in what we call the serial monitor, which we'll see soon. Serial.println is the same thing, but it adds a new line to the end. And then finally, serial.read just returns the first byte in the serial buffer if there's like any available. If there's no bytes available, I think it'll just return junk. So in general, you want to check if there's any bytes available first using serial.available. Yes. Now let's talk about the Arduino IDE serial monitor. It will return what if no bytes? I think it'll return just like unpredictable value, like whatever was last in memory, probably. Okay, Mario also has a question. Is the description in serial print a typo? Probably. Oh, sorry, yeah, that's a typo. It just prints out to the, it essentially sends data. Thanks for catching that. I'll write it. Sends serial data in ASCII format. So I say in ASCII format, like I specified that because there's also a serial.write function, and that sends like the byte. But usually serial.ascii or serial.print, it sends it in human readable form which is usually what you want. It's what you'd expect if you like did a console.log or like a printf in C++. Yeah, thanks for catching that. Now, yeah, so the Arduino IDE serial monitor is something that allows you to see any serial messages that you send out. So it's essentially like the browser's console. And additionally, it could also be used to send serial messages to the Nano using like this text box. Once you send it, then it'll send it to the Arduino Nano serial buffer. And yeah, you know what to do from there. Yeah, so this is a really useful thing for essentially like debugging, because if you want to check what values are stored in certain variables during execution, then you could serial.print it and then check it during runtime using the serial monitor. Also, one thing to note, when you initialize the serial object, which I'll get into like on the next slide, you will specify what's called a baud rate, which means it's like how fast the signal that you're sending can vary over time. And the importance of this is when you're reading something, either like through your serial monitor, or if you're programming the Arduino to read something over serial communication, they have to have the same baud rate to make sure they're like communicating at the same speed. So when you're checking the serial monitor, there is a little like box that you could choose what baud rate you want to use. Just make sure that's the same as the one you're using when you program your Arduino. So let me just note that. Okay. So let's get into a little example now that we know like how to communicate serially. This is actually the other program that Jessica asked you to upload to your Arduino. This is the read analog voltage program. And now we should be able to understand everything in this code. So like I said, when we want to initialize serial communication, the first thing we do is we like start up the serial object that's built in. And we do that by calling serial.begin in the setup function. And then the argument that it takes is the baud rate. And usually you're going to use 9600. So initialize the serial communication. And then in the loop, what we're doing is we're analog reading from the A0 pin. So do you guys remember what range of values that would give you? Can you type it in the chat, please? It's a 10-bit ADC. Perfect. 0 to 1023. Nice, nice. So remember that 1023 corresponds to 5 volts. So if we want to know the voltage that's being applied to that pin, we would need to do some conversion from that 10-bit value to 0 to 5 volts. And in this case, they're doing that using this. So essentially, if you can, to understand this, like think about the boundary conditions. So the values that you could have in sensor value is 0 to 1023, and 1023 corresponds to 5. So if you plug in 5 into sensor value, you would get, or sorry, if you plug in 1023, you would get 5, which is what we expect. Likewise, if you plug in 0, you would get 0. And then all we do after that is print it out, and then we could check that out on the serial monitor. Yeah, so like Jessica said last time, this allows you to sort of probe what kind of voltages are like in different points in a circuit. So you could kind of use this like a voltmeter. Does anyone have any questions? Okay, if not, we could move on. So now we're gonna go into our first exercise and we're gonna do that in breakout rooms. So you guys are gonna be doing this on your actual Nano, by the way. If you so desire, you could do it on Tinkercad. Actually, who wants to do it on Tinkercad first? Just like if they prefer it. If there's at least one person that wants to, then I'll go over how to do it on, like what you need to know to do it on Tinkercad. So just type in the chat if you want to do Tinkercad. Okay, type in the chat if you don't want to do Tinkercad. I prefer Tinkercad, okay. Then I'll go over what you need to know. So let me just share my laptop screen. So if you want to do this in Tinkercad, what you could do is create a new design, create a new circuit. And then the components that you have available to you, there is actually an Arduino. In this case, it's an Uno, but the behavior is the same, okay? Like as the Nano, it's just Nano is essentially more compact and some of the pins are different. So if you want to try out this exercise, all you need to do is drag out an Arduino here. Then you could, like before, do your breadboard. And then for instance, connect like the certain pins. By the way, this one, you don't necessarily need our power supply module, our breadboard power supply module, because the Arduino, if you can see, has like a 5-volt output pin that like it converts the power that it's receiving and like outputs it here. So you could use that. And then to actually program this in Tinkercad, you just go to this code section. And we want to do text because we're hardcore. And then, yeah, then you program this. In this case, it comes default with the blink code. And then once you start the simulation, it will, if you can see, like it blinks here. Yeah, that's basically what you need to know. The last thing you need to know is they also have a simulated serial monitor, which is accessed by going to code. And then down at the bottom, there's the serial monitor. So if I like, I guess serial.print, but then I would have to initialize the serial object, right? 9600, let's do. Then if I start the simulation, you see meow. And note that I'm using serial.print, which is why there's not a new line. It's just continuing on the same line. Okay. So let me go back to our exercise. So in this exercise, what you are going to be doing is with one Nano, an LED, a 1K resistor, and a push button, you want the following behavior. You want the button to essentially act as a toggle. You guys all know by default, the push button is not like a toggling behavior. It's like a holding behavior. So when you hold it, it's on. We want to convert this using our programming knowledge to allow it to act as a toggle. And when the LED is toggled on, we want it to fade from lowest to highest brightness. Yeah, you guys should have everything you need to know to do this. One thing, I'll give you one hint. For the toggling behavior on the push button, we're going to want to initialize whatever pin that's connected to as an input pull-up. So And if that doesn't make sense to you right now, don't worry. If you have more time to think about how you want to approach this problem, maybe you'll get to the point where you realize that you'll want to use this. So yeah, does anyone have any questions about the exercise? And if not, then we'll go straight into breakout rooms. And yeah, so let's open the rooms. And yeah, like I said, feel free to use Tinkercad first if you feel more comfortable with that. I'll see you guys later. So first I initialize some global variables that I'm going to need. So I have the button pin, which is pin 2, like you saw, and then the LED pin, which is pin 3. This is a common thing you'll see in Arduino programs. They always initialize some globals that correspond to certain button pins you're going to be using or certain states or variables that you want. Then I have what I'm going to store as the previous button state. And when I say button state here in my program, it means whether I'm reading high or low on pin 2. And then I have a brightness level, which corresponds to how much I'm going to analog write to the LED. And then I have another variable called fade amount, which determines how fast or slow I'm going to be fading. So in the setup, all I'm doing is initializing serial communications just for the sake of debugging. And then I'm setting the button pin as an input pull-up. And if you guys can see, the reason I specify as an input pull-up is because when the button is closed, or sorry, when the button is open, what do you guys think we'll be reading from this number 2 pin? And the answer is we don't really know, because it's easier to see in schematic format. But when the button is open, whatever the pin is reading is some internal thing, and we can't be sure that it's either high or low. However, when the button's closed, we know for certain that pin 2 is going to read 0. So when we specify this pin as an input pull-up, when the button is open, it will guarantee us reading 5 volts on that pin. So essentially, if I close the button, pin 2 reads 0. If I open the button, pin 2 reads 1. Okay, now in the loop, what I first do is I check if the button is toggled. And I do that with one if statement. So I check the current reading of the button pin. If that's not equal to whatever the previous reading of the button pin was, and if the previous button state was low. So that means if I'm going from low to high, then I should toggle. Then in that case, I toggle LED state. So if LED state's true, it becomes false, vice versa. And then I update the brightness, which just means I update how much I want to analog write to the LED. And so if LED state is true, which in my program means I should be fading, then I change the brightness by the fade amount. And then I do one more check, and that's if, remember when I analog write, I can only do values from 0 to 255. So if my brightness exceeds these values, then multiply the fade amount by -1 essentially. So that makes it so that the next loop, if I'm still on, then this is a subtraction, essentially. Otherwise, if the LED state is off, then just set the brightness to 0. And then for every loop, I write to the analog pin the brightness level. And then I update the previous button state to be essentially the current button state. And then I just have this delay of 10 milliseconds so that the loop doesn't run too fast. Does anyone have questions on this? I know it was a challenging problem. How come you didn't need to set up the pin mode for the LED? Oh, yes, I did not mention that. Actually, I could have, but if you see the Arduino documentation, the language reference that I mentioned, then let's see. I think it's in pin mode. Sorry, no, I think it's an analog right. It says you do not need to call pin mode to set the pin as an output before calling analog right. It's just some Arduino thing. I could set it as an output pin, but it wouldn't make a difference. Good question. Any others? Did everyone follow my code? Is there anyone who kind of got lost as I was going through the code? Okay, Mario raised his hand. Yes.
What you just mentioned about not having to do the pin mode for the LED is it bad if I do it always anyway, or?
No, it's not bad. Actually, in fact, I would say that is probably better practice, just so when you read your code, you know for sure.
But it's good to know that though.
Yeah.
All right, thank you.
Anyone else?
Are you gonna post the solution on the slides?
Yes, I will. Okay, so I'm assuming everyone followed this. In that case, let's move on. Okay, so now we'll get into interfacing with some sensors that we have in our basic training kit. But first, I'm going to quickly talk about libraries. So Arduino libraries are just like, they're just like C libraries where you have some pre-written code and you don't want to reinvent the wheel. And these often come with your different sensors that you're going to be purchasing or provided with. And so to install a library, there's like two main methods. The first is going to be through the library manager. And to get to the library manager, you just go to tools and then manage libraries. Then it pulls up the library manager and it's really intuitive. You just search for the library you're looking for, and then you just click install. By the way, to know what library to look for, when you get like some sensor you've never used before, the first thing you should do is just like Google how to use it. And then in like some example code or whatever, you're gonna know what library to install. I guess in our case, we'll be telling you which ones you need though. Sometimes though, there's like, you have some odd sensor or you need some library that isn't available in the, I guess, Arduino database. So it won't show up in library manager. If you're in that rare case, you could manually download it. So Arduino libraries are almost always hosted on GitHub. They're all open source. So what you could do is just go to their GitHub page, and to do that, just search for the Arduino library, and you could either navigate straight to the GitHub page, or there might be an Arduino reference page, which will link you to the repository. And then what you could do is download this as a zip file, going to on GitHub code, and then download zip. And then in your Arduino IDE, go to sketch and then include library, then add a zip file. And then just click the one that you downloaded. Additionally, I guess you could clone this repository and then manually add it. But yeah, this was just more convenient, I suppose. So the first sensor, or I guess it's an actuator that we're going to go over, is a servo. And this is our servo. Let's see if I can everyone get out their servo, please? All right, does everyone have their servo? Sorry, mine is just stuck. Okay, so our servo is basically, it's literally the exact same thing as this picture. So you have a brown wire, a red wire, and a yellow wire. And so the red goes straight to VCC, and VCC would just mean 5 volts. And then the black wire goes to ground. And then the yellow wire is what's called your signal wire. And that would go to any output pin. Yeah. And I guess something I should note here is VCC isn't always going to be 5 volts for each sensor. To know what VCC should be, what you have to do is search up the sensor and check what operating voltage it should be at. In this case, it's 5 volts. So this is the basic usage of the servo library. So the servo library is actually built into Arduino. If you guys want to double check that, go to the library manager, search up servo, and then it should say it's already installed because it's built in. But yeah, so for the servo, the necessary things you need to do are to include it, of course, include the library file. Then you always have to initialize some servo object. Now this class is from this library. So create an object, here we call it myServo. And then in setup, you need to call the attach method of the servo object. And this method takes a pin number. So here we attach it to pin 9. That means we attached our input or our signal pin to pin 9 on the Arduino. And then in the loop, we just call right, which takes in an angle. So in this case, it would rotate the servo from like 0 degrees to 180 degrees. And this library is actually not complex, but let me show you what the process is of like looking at some library stuff. So essentially, if I receive a servo I never used before, I search like how to use the servo, and say if I've already done that and I realize I need to use the servo.h library. So I would search like Arduino servo library. And then here it is. And this is what I meant by like the Arduino reference. You could go to the repository, which would navigate you to the GitHub page where you could like download it as a zip or whatever. But we already have it downloaded through the manager. So this page will be available for most libraries. And so down here, you could see all the available methods that you have. We used attach and write. And then you could use these other ones. Just like click onto them to see what they do. If you run into a sensor that doesn't have the methods referenced here, try going to their GitHub and then seeing if they have any reference stuff here. Here they just link, I think, the same thing. But it'll either be here or they might have like some docs like this. So you see API, then it lists the different methods that are available to you. And in the worst case, if there are no like reference sheets available for the servo, or not for the servo, for the sensor, you could look straight into their source code. So you could see like this is the file that we're including, and you could look at the different like available methods and stuff, and then trace the stack to see their implementations and what they do. Yeah. Did everyone understand that? Was that clear?
Quick question for the library manager thing.
Yeah.
um, how how do I like install it? Cause I'm like kind of confused. Like, 'cause I'm trying to install
Sure.
mine.
Let me. Okay, so to install some library with the library manager, you go to tools, manage libraries,
Uh,
and then that will pull up the library manager. You could see this, right?
yeah, I can see it. Yeah.
Okay, good.
Okay.
And then as soon as it updates the libraries, let's see. Sorry, just waiting for it to update the list of installed libraries. I guess my MacBook's on its last breath. Can you guys see the
I think
wheel?
I got it.
Okay, great.
Yeah. Thank you.
Let's see
though.
if I could actually exit this. Oh boy. Okay. All right, nice. So everyone's clear on libraries and stuff? All right, then I know this is like a quick example of how to do the servo stuff, but if you didn't follow along fully, just look at the reference stuff that I gave you, or just like ask me or Jessica on Discord. But this library is very intuitive. It has a great user interface. So it should be self-explanatory. So we're already going to get into 2 exercises. And I think for these, we'll have until 8:45 to do them. No. We'll need a bit more time for the other stuff. So we'll say you have until 8:40. And then we just go over buzzers. And then for a take-home project, you guys are going to implement something, we'll see. So you have 20 minutes to do these 2 exercises. The first one is going to be a servo knob. This one is actually an example code from the servo library. So if you so desire, you could look at the example for that and just like copy it. But I really encourage you to try on your own. And then if you get stuck, you could reference that to see what next steps you should take. So in this case, you have a potentiometer, a servo, and the Nano. And then as you rotate the potentiometer, it should rotate the servo essentially. And then the other exercise we'll be doing is practicing like with serial input essentially. So what you guys are going to be doing is you just have the Nano and the servo, and then you will input like integers into your serial monitor and send it to the Nano. And then whatever you sent should be the angle that the server will be set to. For this, I encourage looking at the Arduino serial object reference. So just search that on Google, and then you could see the different methods available. Look at serial.parseInt. Yep. So does anyone have any questions before we get started? Okay, then we'll open the breakout rooms. And I'll see you guys at 8:40. Okay, so now that everyone's back, I'm sorry if that wasn't enough time. I know that was really quick, but if you guys didn't finish, you could quickly just follow along this solution, or If you want, go through it on your own time at home, but I'll quickly demonstrate what it should be. So here is going to be exercise. Sorry, I'll do exercise 1. So this is the behavior you should have. So essentially, as I move this potentiometer, it moves the servo. And I'll go over the code for that. So quickly, I just have, sorry, this is so sensitive. Okay. For the potentiometer, I'm essentially using it as a voltage divider just on its own. So as you can see, 5 volts is being applied to one edge pin and 0 volts to another pin. And so you can kind of see that between the middle leg and the right leg is 1 resistor. And then between the left leg and the middle leg is a different resistor of a different value. So if you remember Jessica's voltage divider lesson, then this is just a voltage divider. So when I move this, the reading on the middle pin will be different based on the ratios of the resistances. So I have this pin, I'm reading the voltage divider at pin A5, and then I have my servo pin as pin 2. So here's the code for that. It will be this one. And so first, I just include the servo library. I set my servo pin. I initialize my servo object. And then I have a variable that stores what angle the servo's at. And then in my setup, I initialize serial communication, and then I attach my servo to the specified pin. That should be clear. And then in my loop, all I do is I update the angle to be the reading of the analog read value of A5, which is my voltage divider pin essentially. And then I convert that to 180 at max. So this will vary between 0 and 180. Okay, I hope that's clear. Now let's quickly go over example 2. So in this case, no potentiometer, it's just the same setup, but without the pot. So I'm powering the servo and then I'm connecting it to pin 2. And the code for this is simply, I do the same thing. I have the servo pin, the servo object, and the angle. And then in my setup, it's the same. Initialize serial communication. This one's actually important for this problem, of course. And then I attach the servo pin. And then in my loop, I just check if there's anything available in the serial buffer. So I actually didn't demonstrate what this should look like, but I will in a second. And then if there's something available in the serial buffer, I set that to be the angle, and then I write the angle to the servo. Now, in this case, I didn't do any checks for whether what I'm getting for angle is valid, but if I wanted to, I would say like, if angle is between 0 and 180, then write it, essentially. So this is the behavior that you're going to want. In the serial monitor, if I type something, say like 120, and I send it, remember this sends it to the Nano, then it will go to 120 degrees. If I send 180, it will go to 180. If I send 0, it goes to 0. So that's what it should look like. Okay, I know that was fast. I'm sorry. If you guys are curious on how that works more, you could Discord me or just look back at the video. Yep. And we have one final thing to go over. It's another long session. I'm sorry to keep you guys. But yes, the last thing we're going to go over is buzzers. So the buzzer is just the little circle thing. Does everyone have their buzzer? You guys should see what it looks like on the basic training parts list. So please get your buzzer out. Does anyone not know what the buzzer is, actually? Let me just make sure everyone knows. Type in the chat, please, if you don't know. Okay. So everyone has their buzzer. So what you need to know about the buzzer is the polarity matters. So you have to connect the positive voltage to the side that has the plus sign on the buzzer. Okay. And then for us, we want to play some sounds with it by applying voltages across it. And we just want to put a series resistor, just like as a current limiting resistor. So this is what sort of like the basic buzzer connection should look like. An output pin going to the positive rail of the buzzer through a resistor. In this case, I'm using a 100 ohm resistor, so we'll, I guess, use our 130 ohm resistor. And then, yeah, it just goes to ground. And the cool thing is Arduino comes with a built-in function called tone, which plays a specified frequency tone on a pin. So you could see that in this code. What this code will basically do is just once you upload the code or press reset, then it will play a 5000 hertz tone on pin 7 for 500 milliseconds. Note that this is optional. If you don't specify, it'll play indefinitely. And if you want to figure this out, remember the language reference that I talked about? Yeah, that's going to give all the built-in functions and stuff. So this will show up on there and you could, you would be able to find out that this is optional. I just want you guys to get familiar with like referencing the documentation because that's a really important part of programming in general. And Mario asked, the volume depends on the resistance, right? I think so, yes. Okay, so don't quote me on that though. I'm not 100% sure. Okay, so does anyone have any questions about the buzzer? Then if not, we will get into our project, the Arduino. And so in this project, you guys are going to be doing this at home. You're going to design a circuit with a Nano, 2 buttons, a buzzer, and the 100 ohm resistor, current limiting resistor, which behaves according to these specifications. So if you press the first button, then it will play your favorite song through the buzzer. And then if you press button 2, it'll play your second favorite song or whatever song you want to play. And then feel free to like add other stuff that we've already gone over, like servos, LEDs, and such, that maybe like moves to the music or whatever. Yeah, I mean, there's nothing really more to the buzzer than this like tone function essentially. I will add, actually, I'm gonna post a header file. Give me 1 second, I'll post it in the Zoom. And this header file will just contain a bunch of macros that that map different notes to their specified frequency, so you don't have to hard code the frequency value. And I will send the link to that now. Can you guys double check that you can view this?
So as we need
And-
access.
Oh, you need access, okay.
Yeah, I said access denied.
Okay, my bad. How do I? Share. Okay, anyone with the link? Okay, it should be accessible now, is it?
Yeah, works now.
Okay, thank you. Yeah, so if you look at this, it's just a bunch of macros. I didn't write this. I got this online. So if you want to know more about the different, like how to use this, if you see it, I'll quickly go over it. You have all the different notes. And then I think like the last number is the octave. If you guys are familiar with like music, which I'm not really. But yeah. Is that clear?
I have something to add to make this like a much more fun competition, make it a competition, but like this is the homework. So we're asking you to make like a 30-second video of like pressing the buttons and playing the songs. And if you're like the first 2 ones to submit it, then you can get some gift cards into this form. Can you guys make sure you can access this form?
Oh, we don't have
It says we need
permission.
permission. Yeah.
Does this say like name and video link?
It only works on the UCLA account.
Oh, okay. I'll fix that, but yes, I'll post that on Discord again, but I'll fix that.
Austin, I have a question about the buzzer.
Yeah.
So does the third optional parameter was the duration of playing it, right?
Yeah.
But then does that basically function as delay? Like, does it hold up all the rest of the code and wait for it to finish running and then it goes to the next?
Actually, that's a good question. It does not. So it's
Okay.
more like, I guess it would act more like if you implemented it with Millis.
Okay, so then we would actually have to write it as like write the tone and then optional duration and then have another delay after that. So that way you don't start layering like. Okay,
Yeah.
Thanks.
As I am like 95% sure, but you could quickly double check that. Or if you want, I could quickly double check that, then I'll post like an announcement on the Discord.
Okay, I mean, I'm sure when I test, I'll figure it out.
Okay, great.
Yeah, thank you.
Yeah. Good question. Does anyone have any final questions?
I do have one.
Yeah.
I was wondering, is there a way like to how do I say it? Let's say that you just uploaded something to your Arduino.
Mhm.
Is there a way to make it stop doing what it is doing until I like? Let's say that I need to make some fix to the code. Is there a way to reset it so that it stops doing what it was doing, or I should just
So-
have to upload something empty first?
I would just like unplug it.
Okay.
That's basically what you do. Yeah.
All right.
Yeah.
Okay.
Good question. Any final questions? So if today was too fast and you were a bit lost, can I get type lost in the chat if you didn't really follow today's lecture, or if you don't want to type it in the chat, private message me in the Zoom right now, or if you get lost later on, message me or Jessica on Discord and we'll help you out. But I know today's lecture was fast, so don't feel discouraged if you didn't follow everything. But I do hope that at least now you feel confident in at least making simple circuits with your Arduino. Don't use the examples that we did as a baseline for like how good you are or like how much you know, because I tried to design the examples to be quite challenging. So that's not like what every Arduino project is going to be. It's not always going to be such a headache like this. So yeah, I just hope you don't feel discouraged and that you continue to learn more about Arduino and that you're excited about it. Yeah, so, okay, Cameron doesn't feel lost, thank you. Gabriel, yes, you could definitely message me on Discord. Yeah, so Amelie asks, when should we shoot to have the iPod Arduino done by? Jessica, do you have?
So I'm gonna wait. So I'm gonna ask like the first two. So like as soon as possible, I suppose. So the first two to meet the criteria. Oh, the chess piece. I'm not sure yet. I think they're working on this like when you guys come to the makerspace, I think that's when you will give it to us. But Daniel, can you double check? But yeah,
So-
so
So I think the
Go ahead.
prizes are going to go to the students who get their iPod Arduino done first and second. But we would like all of you to submit your recording of your iPod Arduino, and we're going to showcase some of them at the Makerspace on Saturday. Rudy and Daniel, you guys need to figure out how you're going to get the student submissions for the CAD designs before Saturday. Can you guys please work on that and post it onto the Discord channel, please?
One final remark is, since this is like a speed competition, I guess most of you guys are going to choose like quick songs, but I guess like if you're really chasing for the moolah, then do that. But even if you do that afterwards, then try to tailor it to like a song you actually want to do to make the project more personal. Yeah, that's it.
we
Thank
make
you,
it to a more
everyone.
difficult song.
Yeah. Okay. Should we post the feedback form and then everyone can go?
Sure.
Thank you all for attending today.
Okay, hold on. We're not done yet. I have a
Okay.
few last final reminders. So I wanted to talk about the Saturday session. I'm going to share my screen. Give me a second. Okay, so if you go to the accelerator website, can somebody give me a heads up that you're seeing the website? Thumbs up. Thank you. All right, so if you go to basic training, okay, so the in-person Makerspace tour is on Saturday, this coming Saturday. The Makerspace is located in Bolter Hall, room 1805. That is the room that is near where we were waiting for you all if you came to UCLA to pick up your parts. If you didn't come, then I have some direction sets here. And so what's important to note is if you're using a navigation system to find us, do not use the physical address for Bolter Hall because it's going to put you on the wrong side of the building on the wrong floor, and it will be really hard to give you directions on how to get from there to where we are. Okay, so what I'm suggesting is that you use the address for Engineering 4, which is a building right off of Westwood Plaza. That is 420 Westwood Plaza. And then I've provided you some directions. If you are driving and parking, there is some pay by the hour parking spots on the rooftop of parking structure 8. The ramp to get to the rooftop is a little bit hard to find because it's not a street in itself, but it is at a traffic light. And so if you read through these instructions, it'll be really clear. But I do encourage you to read the instructions before you take off on Saturday so that you can kind of like have a mental image of what you're supposed to do as you get close to UCLA. Okay. Thankfully on Saturdays, we're not too busy in the Westwood area. And so, you know, if you miss it, you can turn around and try again pretty easily. And then walking directions to the makerspace from Westwood Plaza, again, from Engineering 4 is basically you're walking behind the building. And the room in Bolter Hall is located between Engineering 4 and Bolter Hall. Okay, so there's some instructions here on both how to find UCLA and Parking Structure 8, as well as walking to the UCLA Engineering Makerspace. It is important that if you're asking directions, that you're asking for the makerspace in the School of Engineering, because there are other makerspaces on campus. Okay. And so, from the outside world, people will likely know where engineering is. They may not know where the engineering makerspace is, but at least you'll be in the right area. Okay. And then things to bring, make sure that you bring your ID. We're going to only allow basic training participants in. I'm kind of saying that just because this is a public facing website and I don't want the public to be joining us at our session. But just bring it just in case, okay? And then probably bring some water because we'll be there for a while. And then when we're in the makerspace, you do have to bring closed-toed shoes, okay? You cannot wear sandals or anything like that in the makerspace, okay? Also, if you have long hair, make sure that you bring something to tie your hair up, because we don't want your hair or loose clothing to accidentally get caught in the machines and tools that we're going to be using. Okay. I'm getting distracted by the comments in the chat. All right. Anyway, so make sure to, again, your ID, no baggy clothes, closed-toed shoes. And then if you have long hair, bring something to tie your hair back. And then obviously something to take your notes on. We will be doing some fabrication on Saturday. And so Daniel and Rudy, please make sure that you guys are able to get an avenue for the students to submit their designs to you. And then I think it would be fun to be able to see some of your recordings of your Arduino. So make sure to get those into us, and then we can probably set it up to play a few of those at the beginning during our time there. Okay. Other than this, if there's any further details that we need you to know, we'll let you guys know on Friday at our session. Okay. Are there any questions about this? All right, folks. How about a round of applause for Austin? Austin, thank you very much for your instruction tonight. I hope you guys are getting more and more excited about, learning these new kinds of tools and some of the new technologies and sensors. Hopefully you're starting to kind of see how, these things can be put together to be able to actually do some technical work, particularly focused on prototyping, and maybe already starting to make connections with the things that our mentors are teaching you and projects or activities that are interesting to you, right? The goal of all of this is not only to prepare those of you who are joining us for Hack, but really to give you guys some rudimentary tools to be able to tinker and make some of your own imagination come to fruition. And so, hopefully that's the case. And we do encourage you guys to, do the out of class activities and submit your projects to us, because that really codifies your learning, and this is just the beginning. We'd love for you to continue to develop that. Okay. Mentors, do you have any other announcements? I think, Jessica, are you taking the lead on the next workshop?
Yeah. There shouldn't be any more announcements because you guys, okay. So make sure to download the Arduino IDE if you haven't already, and make sure to actually upload like one code and make sure everything works. And if you can't, if it doesn't work for you, definitely message me or Austin tonight or tomorrow morning.
Okay. All right. Thank you all, everybody, for joining us, and we will see you tomorrow night.
Thank you.
Thank you.
Thank you.
Oh, Wes, I have a quick question.
Sure.
Oh, so it's about like Zybooks, right?